Hello, beautifuls. This is Atleen, and I'm coming to you with another YouTube video. So, today we are continuing our discussions on common network architectures. So, let's discuss fastness. In large metropolitan areas are large metropolitan sites like, for example, what I have on the whiteboard. I used Atlanta for the different areas in the metropolitan area. So the first one is Truist Park. The second one is Little Five Points. And got a third one, the Ferris wheel in Centennial Park, and that's in Atlanta. And Martin Luther King Historical Site, that's in Atlanta. And Atlanta History Center, and that's in Buckhead. Truist Park is in Marietta. Little Five Points, I consider it Decatur. So we may have the lavishness of having buildings that are in close proximity to a fiber ring. And as you can see, they're all connected. It's a fiber ring. That surround some metropolitan areas. So let's say that we have this fiber ring. As you can see, the ring. It's a fiber ring. It's connecting. That goes from Little Five Points to Centennial Park to Martin Luther King Historical Site to the Atlanta History Center in Buckhead to Truist Park in Marietta. And it might be running at 40 gigabytes. Forty gigabits per second. That's the proper terminology and technology. 40 gigabits per second. So, based on Ethernet technologies, we are running a MetroE. This is one example of the technology that we can be running. And we did discuss this the other day, the MetroE. And even though you may be across Atlanta, your partner building is, or the sister building is running across Atlanta, it's like we are right next to each other because we have this extraordinary high speed connectivity. And note the ring design. Once we come in with cutter, if we come in with a cutter and we cut that ring, each building will still get to every other building. And the reason why is because the ring itself gives us redundancy. So we're offering metropolitan area network services to our clients, but how do we keep them separate? That's a good question. How do we keep them separate? So I have all these clients, we have all these clients, and they are all the same, they are all using the same fiber. And these different colors of light and that's a fiber optic cable. And these different colors of light have different wavelengths. Red has a much longer wavelength than violet, and violet has a shorter wavelength. So this is where the term lambda comes into play. I don't know if you remember when you were in grade school, lambda refers to wavelength. And this is the term useful in networking. We can say that I have 4 lambdas running on my fiber. Oh, so we have 4 different clients using various frequencies, various wavelengths of the light. And we are keeping those separate, various lambdas, and for the exam Ccna²⁶⁵D³³, this will more than likely be on the exam. Okay, so we're at the 6 mark time frame, and so I would like to read a little bit about the topology, Metro Ethernet, physical design, and topology. And we're going to go to Ccna²⁶⁵D³⁵, Volume 2, Wendell Odom. And tonight we're going to the same chapter, Chapter 14, WAN Architecture. And we're going to read more on Metro Ethernet, physical design, and topology. So I will read. From an enterprise perspective, to use a Metro Ethernet service, each site needs to connect to the service with at least one Ethernet link. There is no need to connect each enterprise router to other enterprise router directly with a physical link. For instance, in Figure 14-1, this is 14-1. In the previous section, each of the 4 enterprise routers connects to the service providers, SPs, MetroE service with one physical Ethernet link, rather than connecting directly to the other enterprise routers. From the SP enterprise perspective, the SP needs to build a network to create the Metro Ethernet service. To keep costs lower, the SP puts a device, typically an Ethernet switch, physically near to as many customer sites as possible in an SP facility, called a point of presence, POP. Those SP switches need to be near enough too many customers' locations so that some Ethernet standard supports the distance from the SP's POP, point of presence, to each customer site. Figure 14-2 collects some of these terms and ideas together. Ethernet access links into a Metro Ethernet service. And as you can see in Table 14-2, the IEEE Ethernet standards, useful for Metro Ethernet access, states 100 base dash LX10, speed is 100 megabytes per second, distance is 10 kilometers. So it varies. As you can see, we have 100 base LX, 100 base LX10, 1000 base ZX, 10 base LR, 10 base ER, gigabytes ER. So I will go to, do I know this already? And it's 1, 2, 7. What we discussed tonight is going to be number 2. Which of the following is most likely technology used for an access link to a Metro Ethernet service? It gives us choices: A, B, C, or D. A is 100 base LX10. B is high speed TDM, for example, T3, E3. C is MPLS. And D is 100 base T. The answer is 100 base LX10. And when we go back, we see that that is true because that's what it has right there. 100 base LX10. Out of all the ones that we get to choose, that's the one that is correct. Thank you for watching, and I wish you well. And tomorrow we will go over SOHO, because that will be on the Ccna²⁶⁵D³³ exam as well. I wish you well. See you tomorrow.